Consumers can have both indirectly and directly positive or negative effects on their ecosystems. Some consumers, such as elephants, can be considered ecosystem engineers due to their extensive modification of their ecosystems. Elephants have been observed to remove or damage branches from trees, as well as topple trees over. These actions create new miniature habitats that are more protected than other portions of the savanna in which elephants live. Researchers conducted a study in the Mempala Research Center and Conservancy in Laikipia, Kenya, to investigate the effects of elephant ecosystem reconstruction on herbivory understory biomass and understory plant diversity. It was hypothesized that herbivory would be decreased under elephant-damaged trees due to physical inhibition of large herbivorous mammals, and as a result that understory plant biomass and diversity would be greater in these areas.
To test these hypotheses, researchers collected data on 117 understory plant taxa over 7 years within 36 1-hectare experimental plots in a semi-arid Kenyan savanna, and they measured the strength and direction of elephant impacts on understory vegetation. It was observed that elephants had neutral effects on most species, 83 to 89%, and a similar frequency of positive and negative responses. The composition of understory plants was monitored using a 10-pin frame that was placed at 49 evenly spaced, permanently marked points within a central 60 by 60 meter grid within each 1-hectare plot. Our Markov chain Monte Carlo approach, paired with Poisson likelihood, was used to establish a plot-specific occurrence rate for each plant species. Plants responded positively, neutrally, or negatively to elephant damage by assessment of their 95% confidence intervals around estimates generated using the Gibbs sampler.
The study consisted of 3 experimental portions: a manipulated experiment that simulated elephants dragging broken tree branches a distance away from the tree, a manipulated experiment that tested fenced-off plots with simulated elephant damage against open plots with simulated elephant damage that were open to large mammal herbivory, and a manipulated experiment that removed elephant-damaged branches to test whether understory biomass and species richness would decrease in the absence of these sheltered areas. To assess herbivory, grazing stars of the 2 most common grass species, Nydon flectosuchius and Aristidia kenyensis, were assessed, and the percent of grass grazed was compared between control and experimental plots.
Studies show that in some cases, elephant-damaged trees resulted in positive effects on understory plants. In one case, elephant damage stimulated an increase between 55 and 21% in understory species richness and biomass beneath damaged Acacia ethbica canopies. Damaged canopy due to elephant browsing also decreased herbivory of the understory by over 70%. It is also found that removing elephant-damaged trees significantly decreased the understory species richness and biomass with respect to controls.
6 species similarly responded positively to the elephant's reconstruction. However, in a larger scope, it was observed that elephants did not have as high of an impact on overall understory species diversity and biomass. 7 species responded negatively to the elephants, and the remaining 89% of species responded neutrally to the elephants. This suggests that while elephants do help understory diversity and biomass in some cases, they are not always beneficial. In most cases, elephants have a neutral effect on understory plant species, but they do alter their ecosystem and both directly and indirectly facilitate mechanisms within the ecosystem.